move on then to notebook number 2, which is on data records. So could everybody please open that up? So now we're starting to do something beyond the basics. So this, like I mentioned, is the unit component of DataFed. This is where you would capture a whole lot of information in this object called data record, if you will. So what I'd like you to do for us before we move forward is if you could look up what this is for your own collection. So if you could look that up and paste it in here. The reason I'm asking you to do this is so that every one of us, we work within the context of a collection initially. We certainly do have some collaborative exercises, but the point is you work within the context of your collection, so there isn't a name clash with another person. That's all. You can do this one, or you can give it the unique ID, or you can give the alias. It doesn't matter this way because we've already set the context to this project. So what I'm going to do is fill it out for myself.
But yes, just to clarify, the C/ is part of the unique ID, because you'll notice that collections have a C/, data records would have a D/, and then username is new /. So yes, include those.
That's a good point. I will just look up what it is in my case. So where am I? So I'm right here. So I will instead use, for illustration purposes, my ID. So I have to copy paste the entire thing. All right.
And that would be unique to everything.
That is correct. It's unique across all of DataFed. So you could do it either way. You can put in your alias, which is a little bit more convenient to put in, or you can put in a unique identifier. That's totally fine. We've gone over this concept of data records before, and I haven't shown you how to create it in the web portal because this isn't a tutorial on the web portal. Let me show you how it's done in Python. Before we actually go ahead and create this record, right? Let's assume that we're all scientists and we have some scientific context we want to capture, whether it is some climate science data or material science data or something like that. There are some parameters for your simulation, or maybe it is some parameters for your measurement or something that you want to capture. The way we do that in DataFed is we capture that contextual information using key value pairs effectively in something as simple as a Python dictionary. And I specifically want to point out this something in bold here, which I'm pointing out as like. It is like a Python dictionary. It's not exactly a Python dictionary. I'll get to what I mean by the like very soon. So for right now, for illustrative purposes, I've just put together, or rather, we've just put together this simple dummy dictionary, which contains some metadata associated with our data. It's just an ordinary Python dictionary. Just a note, it can be nested, so it's totally fine. It doesn't have to be a giant flat listing, as I've shown you in the practical examples before. And the reason I said it is like a Python dictionary and not an exact Python dictionary is because as it stands right now, DataFed expects actually stores and communicates metadata in the form of JSON strings. And JSON strings are almost identical to Python dictionaries. And the way you can go between them is by using a built-in Python package called JSON. And for example, if you want to go from this Python dictionary to a JSON string, you would use this function called json.dumps, or a dump string. So that's what you get back in return. It's basically a string version of whatever we just typed in. So it's almost a dictionary, not quite a dictionary, it's a string. All right. So now with the metadata prepared, and just a note, you don't need to have metadata, but it's encouraged to have the metadata there so that as you move forward in your actual scientific application, you can leverage this information to search upon things and organize data and so on and so forth. So let's say we do have this metadata, we can finally go ahead and use our first important function, which is called data create. As the name suggests, it helps us create data records. It only requires one field as default or required, which is the title. Everything else is optional, as it says right here. But in our case, we'll just call we'll just say that we want our the title for the dataset to be my important data. You don't have to worry about putting underscores, etc. This is not the regular file systems. You don't have to hard code a whole lot of parameters right here. You can just give it any title you want, and then the next part is where we specify metadata. We use the metadata keyword argument, as you can see right here. And in this current version of DataFed, you have to use JSON.dumps. In the subsequent version, you wouldn't need to do that. It'll automatically understand that you're supplying a Python dictionary and convert it in the background to a JSON string for communication purposes. But for right now, we'll just use the JSON.dumps for the parameters. And then you have to specify where you want this record to be created. If you don't specify this keyword argument, what would happen is, let's just go back to the web interface. So what would happen is, if for example your name is Alka and you wanted to work right here, but you didn't specify the parent collection, it's going to assume that, okay, you said I'm supposed to work in the training project, so I'm going to put you in the root. So everything that I'm going to create, I'm going to put it in the root collection, as opposed to within your own space or something like that. This is the reason why I said, let's just everybody capture your parent collection as your own ID or alias. That way we create records, we create collections, etc., within the scope of your own collection and not in somebody else's space and not dirtying up the root collection. All right. So that was the third argument which you want to keep track of, which is a parent ID. In this case, it's your parent collection, which, if you recall, points to whatever was you set this to, your alias or something like that. All right. Then if I hit Shift Enter, we get back a response from DataFed. So it says that I did manage to create this record, and this is all sorts of information about it. For example, it tells me creation time, so on and so forth, and it tells me who the owner is. In this case, because we're all members of the project, we all collectively own this data. So that's why it says the owner is the project itself, as opposed to myself. But it captures the fact that I'm the creator of the data, and then other information like metadata, etc., are already captured right here. As I mentioned before, DLA is thinking about only returning the ID component, which is largely what you would need to go forward and use this information. But for right now, we're still dealing with the large protobuf messages. Any questions so far?
Now you created a placeholder for the data, because I don't see the payload.
That's correct. There is no payload here.
Okay.
I will get to the payload in the next notebook. There's a whole lot of stuff you can do even before you get to the payload. So we only specified a few of the fields. Obviously, we could have specified a description. We could have written a giant essay about it if you wanted to, added some tags, and then defined some relationships using the DEPS dependencies. So we could have done many, many things. But for simplicity, this is all we did for right now. The next step is often, like Jan pointed out, yeah, it's cool that you created the record, but now I want to use it for putting the payload into it, or I want to use it to, I don't know, relate one record with another record or something, right? So how do you do that? So you can do that by finding out the way you can address the record, right? So the way you address the record you just created is using the ID field, which is right here, but it is stuck within this giant blob right here, this message object. So how do you tease out the ID is the next question. So this is something very important, because this is something that you can do in the Python interface, but it is harder to do. Not impossible, but slightly harder to do in the CLI. So this is a tiny exercise for you all. So if you want to take maybe 30 seconds to do it, this is again going to be based on kinds of things we learned right here. If you recall, we were playing with indexing and subscripting, etc. So it's largely going to involve things like this. So the key, again, as I mentioned, is to use the DC_RESP object, which contains this message. So you can just tease out the ID And in the interest of time, I'll just go ahead and solve that for you. Basically, we get the first component out of the tuple, the two-part tuple, and then we ask for whatever is the first field we see here, which is data. And then, assuming that it is an iteration of multiple data, in this case it isn't, we just go to the 0th element and then ask for ID here. And that's how we get to the record ID.
So protocol buffers always assume that the sort of top level fields are iterable?
Not always. So it depends on the message type coming back. Most of these are iterable, but there are some specific cases where they're not. And again, that will be documented at some point.
So again, the behavior of this may change in the future. So you may not even need to go through this giant listing. Maybe what comes out is just a record ID itself. And if you ask for a verbose listing, maybe that's when you get back all the information.
So your recommendation then is if someone were to use this as an API,
yes,
then I should construct basically a set of functions to do the things that I need to do, and then update those functions when you make updates to your API. So I should assume that the API is a little fluid.
For the time being, that's probably a good approach. We're going to try not to radically change the API once we get out of this early kind of fluid state. The idea is not to break historical codes.
Data records, unlike binary files, aren't something that's set in stone. You can always update almost everything about them, with the exception of certain fields like the ID, which is uniquely assigned. We can, for example, if you wanted to change the title, we can, for example, even add to the existing metadata using this function called data update. As the name suggests, the whole purpose of this function is to allow you to change or edit fields or add stuff or even remove stuff from your data records. Earlier, we did specify a title. We can change this to a description if you want, but here we're showing that you can replace the title and add to the metadata. So if I hit Shift Enter, this is the response we get, and it tells me that, hey, I did this update operation on this particular data object. So as you can tell, the title has indeed been updated, which is some new title for the data as opposed to my important data. And if you wanted to make sure that the metadata has indeed been appended, as you can tell in this data update function, it didn't reply with the metadata. So one way to get complete information about a data record is through this other function called data view. So if you hit Shift Enter on this data view, what we get back is the metadata as well. And here we can tell that it has really added this field, metadata is equal to true, as part of the metadata field of the data record itself. So as I mentioned, we're only showing some simplistic things you can do with every function. As you can tell, this has numerous keyword arguments it can take. So you can certainly modify other fields if you wanted to of your particular data record. All right. And in the interest of time, I'll just say that it is possible to extract the metadata out of the data view command and then get it out as a Python object by using the JSON.loads function, which is the opposite of the JSON.dumps function. Now you have access to, if I type metadata, you get back your Python dictionary and you can work on it. As I mentioned to you before, you can also replace the metadata as opposed to appending metadata as shown right here. But we won't be doing that right now. And the very last thing I wanted to point out too is the provenance capability, which I think is very, very cool. As I mentioned to you before, you can show this provenance. You can have a nice big traceable chain of data records which show you that this is the raw data measured at the light source, and it went through 3 steps of processing, and then finally it resulted in figure 16b of this particular journal publication. So that is a capability that is inherent to DataFed through this provenance. In the interest of time, I will give you all the code. You can copy paste the function that we had before for the previous data create command if you want. Let's say we're doing some data processing and we wanted to create a new record for process data, or let's say we're going straight to a figure or something. Let's assume we're in that mode, and let's try to work through this one last example, and you can see what I mean by provenance. So I'm going to say my parameters are P is 15, and then Q is an array of some numbers and some string right here. So that's my set of parameters. And then I'm going to give it some title, which would be processed data. Oops. and then metadata equals JSON.dump string of new params. Oops. And then I can say my parent ID, because I want to create within my own collection, is parent collection. Oops. That should be it. And we should be, oops, did I do something stupid there? Oh yeah, I didn't put a comma here. There we go. If you follow along and if you did something similar to myself, what you should have received after you execute the cell is a new data record ID. We can specify relationships like I mentioned using DataFed, and there are 3 kinds of relationships derived, comprised of, is a new version of. So what I can do is use this data update function, which we just used before. However, we didn't use this keyword argument. Now that we have 2 records, we can certainly establish a relationship between our new record and the previous record by saying that this new record is derived from the older record. And that's what this is going to do. As you can tell from the response, you get that we've established this dependency here. As you can say, it is derived from this other record that's right here. And the one thing that I want you all to do as an exercise is to visit your DataFed portal and dive into your own particular folder or collection, if you will. And then, as you can tell, I've been trying this out numerous times. And then in this case, as I mentioned before, I created this new record called process data. And I found that particular record here. I use process data right here. And then I can click on this provenance button right there. So I click on the provenance button, and as you can tell, that the process data is dependent on this older data set, and that's how I got to this process data. And this is a very simplistic demonstration, but you get the idea. You can build a genuinely complex system, and you can capture the entire provenance going all the way from your raw data from an instrument or a light source or whatever have you, all the way to the individual figure files like a PNG file or a SVG file going into a particular paper. So now we can also capture the provenance and the versioning, etc., within DataFed. So this marks the end of the second notebook. There are numerous other things that I wanted to cover, but it looks like we're out of time.
Well, also, I think everyone's welcome to, continue with the notebooks. I don't know if you put notebooks up there with the answers provided.
Yes, I'll put all the solutions up as well.